Cookbook for the Universe from Einstein's Insight to New Frontiers, Understanding Mass Through Relative Gravity. Introduction to Einstein and his formula. Albert Einstein revolutionized physics with his profound insights into the nature of the universe. Born in 1879, Einstein's work reshaped our understanding of space, time, and energy. His theory of relativity, which includes the iconic equation E equals mc, brought to light the mass-energy equivalence. This equation reveals that mass m can be converted into energy E and vice versa, connected by the speed of light c. This insight showed that even small amounts of mass could unleash vast amounts of energy. Historically, this discovery has led to breakthroughs like nuclear power, revealing the profound connection between mass and energy. Einstein's equation E equals mc was a monumental step forward, revealing mass-energy equivalence. Relative gravity reinterprets this formula by viewing mass not as static matter, but as energy in motion. Explored is how mass m is expressed as m equals ec, where energy E, including light itself, oscillates at the speed of light squared c. This means mass isn't a fixed entity, but a dynamic form of energy. Crucially recognized is that light photons itself is a form of mass oscillating at the speed of light c. This highlights that different forms of energy oscillate at varying speeds. For example, we know of either c or c depending on context. This dynamic perspective transforms our understanding, showing mass as energy, distributed across spacetime, leading to new insights into gravitational phenomena. By embracing this reinterpretation, we enter a new frontier in understanding the universe. This perspective forms the foundation of the theory of relative gravity itself, which led to the Cookbook for the Universe. With this framework, we can reimagine the universe in terms of manifolds, dynamic structures that represent how energy and mass interact across spacetime. These manifolds capture the complex and interwoven nature of the cosmos, providing new insights into gravitational phenomena and the nature of existence itself. By Ryan Carl Daly 1. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe.